Can everybody hear me? Okay, welcome to Breaking Ground. I would like to welcome to our first talk of the day in here. Big thank you to our sponsors for making this all possible. Otherwise, I'd be at home wishing I had money to go to Black Hat. This is Alan Robertson. He'll be our first speaker, talking about automating security with the OWASP Assimilation project. And with that, I'll hand it over to him.
Thanks. As he said, I'm Alan Robertson, and this is about an open source project which is recently affiliated itself with OWASP. It has security aspects and non-security aspects as well, so you might hear of it as the OWASP Assimilation Project, or you might hear of it as just the Assimilation Project. And a little about me. I spent a long time in IT, coming up on 40 years actually. And I founded the Linux HA project, or Pacemaker. People here heard of Pacemaker for failover or Linux HA? I founded that project, ran it for about 10 years. And I started this project in 2010, inspired by some work I was doing for the government on a 2.2 million core supercomputer. And it was not a normal cluster. It had one clock for everything. It wasn't like a bunch of machines operating separately. And it started making me think about scale in a way I'd never thought about it before. And that's what prompted me to start this project. And I started a company around this in 2013 after IBM showed me and 8,000 of my closest friends the door all at once. And I worked at Bell Labs for 21 years, worked for SUSE for a year, and IBM for 13 years or something like that. So let's go on. As you think about security, how many people think that it's easy to get good security staff? Okay, do you think security is going to get better anytime soon? Do you think you have enough staff, if people were to switch to DevOps or Agile things, do you think that that's going to make your problems easier and you're going to be able to keep up with that? What's up with you guys? What's up with you guys, right? Oh, experience. There we go. That's it. Now, something else that's true about me is sometimes I make claims which seem a little outrageous. Sometimes people, and I'm told they don't let you bring in rotten tomatoes and eggs, so I brought some for you. And so you folks can, oops, that's I shouldn't do overhand throws. I hit people when I do that. So, yeah. There we go. So if the time comes when you say, I know why his eyes are brown, it's full up to here with, that, brown, then you'll know what to do. And I'd never thought about it before, but I guess what I did is armed the audience. Maybe that's not such a good idea at a security conference. So let's think about things that happen here that people don't do really well. 30% of all break-ins come through systems that are not in the inventory. Oh, we had that system? Well, I didn't know. Were we patching it? No, maybe not. Maybe not. Didn't know it was there. 90% of everybody has had failures of services that they're not monitoring. And this is, by the way, this statistic from James Turnbull comes from people who are running Chef and Puppet, which are bleeding edge compared to the industry as a whole, right? That's as good as it gets. And of everybody isn't monitoring all the services they know they have. 71% of people, once they get in compliance with something like PCI, a year later, we're not in compliance? Oh, what happened? I don't know. 30% of people, we really only start monitoring things once they break. And these are of the best people in the industry, right? So how many people think the real world is probably worse than this? Yeah, exactly. 30% of systems aren't doing anything useful at all, but they are making a nice contribution to global warming. They're space heaters, right? They're space heaters. They're doing nothing. These are all other people's statistics, which I have every reason to believe are reasonable, and I think you guys have seen the same stuff yourself. When I talk to people who work in security, they say, yeah, but you should have met my customers. You wouldn't believe what they did, and they go on to tell me something that, I kind of do believe it, unfortunately. So a little about what this project is for, and I apologize for the size of the, that's not interesting. It's not, there's some things not, that's interesting. So anyway, sometimes your animation doesn't work right, So we do things like track IP and MAC addresses, continuously validate configuration against compliance rules. We track software versions. We track checksums of network-facing processes, monitor status of servers and servers and services. Score. We produce scores for your machines, basically risk scores. You know, it's like golf, except you can actually get 0 in theory. Low score is better than a high score. So you can think of it as correlated to risk, sort of correlated to risk. You know, anybody who's mechanical scoring is never, who can agree on what the risk is anyway? But the point is that the low numbers are better than high numbers, right? We also discover the same kind of things for Docker containers as well as VMs and bare metal and clouds. We can help you alert on changes in configuration or status so that you can actually be aware of when things happen. And we do this in approximately sort of real time like. That is to say within minutes to hours of when the changes are made. That doesn't mean daily, annually, or quarterly. That means when they change. And we do it with basically near zero configuration, and we do it without any pings or port scans. So, you know, it's always bad when you have a security tool that sets off your other security tools. That's a bad thing, you know. So you have to turn off your other security tool in order to run security tool A to be able to run security tool B. So this is what we do, and we do all these things together in a way that scales really well. And by scaling really well, I mean it's like on the order of 100,000 systems. So this is when I make this kind of claims. This is where people start thinking that maybe those eggs and tomatoes are good ideas. We do our continuous discovery. We do this continuous discovery, which drives everything, and we create from that a configuration management database, logically similar to the graphs that are passing around through the audience now. The discovery is done in a way that we don't actually do any network footprint to discover anything. Now, to communicate the discovery, yeah, we do that. We do talk on the network to do that. You got to get the data there somehow. Discovery, though, interestingly enough, eliminates most configuration. It is not quite configuration-free, but it's pretty close to configuration-free. So the thing about configuration, how many people think when you configure stuff, it stays configured correctly forever? No, right. Oh, it's that experience thing you talked about. That's it. Yeah, so if it's configured automatically, it's more likely to be configured correctly. We also drive best practice analysis, which you could also say is compliance analysis, because fundamentally, whether you call it compliance or whether you call it best practices, the idea is you want to be following some rules that you think are good ideas, and when you don't, you want to know. Whether that's an official audit process or whether it's just good hygiene on your computers, I don't care. It comes to the same thing. And people say, well, that's just the basics. Okay, most people don't do the basics very well. So let's start by doing the basics well, which is a lot of what we do here. And as I said, we put it in a graph database, which basically means a graph database is basically like what you draw on the board. You have circles and arrows. You know, relational databases have tables, rows, and columns. In a graph database, you have nodes that have attributes and relationships, which are the arrows, that have attributes. So it's circles and arrows in a database instead of tables. The nice thing there's a number of nice things about it, but I won't go into that a lot more, but it's in a graph database instead of a relational database. So scalability without a lot of extra complexity, you know, this is just out of the box. Discovery without pings or port scans? How many people think that sounds reasonable? No, okay, guys. I guess I should have said, how many people think that doesn't sound reasonable? Yeah. Sounds like that maybe this is a good opportunity for those tomatoes and eggs. But hang on a second here. Let's look at the scalability aspect, because this is my favorite thing to talk about. So I can explain how we scale so that your grandmother would understand, even if your grandmother isn't Grace Hopper. So at my church on Wednesday night, we get together for a meal. We stand around, hold hands like this, you know, and we're kind of a circle with our eyes closed. And while we're there with our eyes closed and the pastor's praying over our food, if Aunt Sally passes out, who notices first in this arrangement? The two people holding her hands. Now, for you to participate in this human monitoring arrangement, how many hands do you have to have? How many? There we go, 2. You have to have 2 hands because everybody doesn't have, pretty much most people have 2 hands. And so if I had 1,000 people to that arrangement, How many hands do you have to have? Do you have 2,000 hands? Oh my goodness. I said, how many hands do you have to have? You have to have 2 hands. Right, did anybody's work go up because I added 1,000 people to the arrangement? Nobody's work went up. So that's how we scale. We have our computers hold hands. Well, okay, they're actually heartbeats, but if you wanted to get like really literal, you could put your fingers on their, feel their heartbeats through their hands. And that's literally what we're doing here. We're exchanging heartbeats with 2 neighbors. And now the interesting thing is, now if you have this kind of arrangement, everyone is being monitored by 2 other people. So you can reliably know if a machine goes away, and you can just sit back and wait for the phone to ring, wait for someone to call 911, and you don't have to do anything at all because the monitoring is all fully distributed among the systems that are being involved. So that's how it works. That's the fundamentals of how this scales the way it does. And once you have the scalability, then with agents, everything else falls out. Because you can have a system. How do people think people like to change systems? Or is it more that people, when you screw with them, you mess them up, right? People like to leave them alone. So once you've told us your configuration, we only get notified about changes, which means that we might have a machine we haven't heard from at all for a year, but we know exactly what its configuration is, and we know it hasn't changed. Because we have a reliable way of knowing if that changes through our agents. And if our agent goes away, then the 2 neighbor agents complain that it's dead. So we'll know. It's a nice, reliable way of doing. It's no news is good news, but it's reliable at the same time, which is sort of contradictory, but it actually works that way. So a little about the architecture here, and now we're going to do a demo here in a minute. Let's see how far I am into this. I'm about 12 minutes in. So there's a central system called the Collective Management Authority. This is the Assimilation project, and yes, we have nanoprobes we inject your machines with so that they can be assimilated and join the collective. Those of you who don't know Star Trek might not appreciate the joke, and the rest of you may be groaning. That's okay. I'm okay with bad jokes. They're here somewhere. Now, bad jokes don't count. Just if I'm full of brown stuff. Oh, they're over here. So I did actually collect an egg once, but I deserved it. I sort of drew it. You know, like you can draw a fowl? I drew an egg. So we have nanoprobes, which are the agents on all the machines, which then do the heartbeats and then do the discovery and do the monitoring and send everything to the central server, but only when it changes. Only when it changes. And the nanoprobes are written in C, the central server is written in Python, and we have this graph database that we use called Neo4j, which happens to be written in Java. I don't particularly care, I talk to it over REST. Here are some kind of analysis of reports we provide. Comparison against best practice hardening rules. They default from a project called the IT Best Practices Project, which is an open source project whose purpose is to collect particularly hardening type rules, things you can observe mechanically, which people think are a good idea to be in compliance with. Most of the rules there were taken from the DIS-STIGs, which are mostly good rules. Some of the implementations of them, sometimes people have are bad, but they're mostly pretty good rules. Might be a little excessive, but there's nothing really wrong with them either. Unknown IP addresses. No, it's what IP addresses are out there that we don't know what they are. We monitor services as well as I think I mentioned this, and we can tell you what services are unmonitored. And we do a triage. So imagine that you have 100, let's say, for example, for the DIS-STIGs, there's about 250 rules for a Linux box. And the average machine is going to fail about 100 of those out of the box. So if you have 1,000 machines and each one has 100 failures, you have 100,000 failures. So now you need a way of approaching this to let you eat this elephant in a rational, reasonable way. So we provide a scoring system and a triage sort order that basically says, here's the machines with the most problems, or if you prefer, here are the areas and rules that cause the most problem across all the machines. And you can do it either way, and of course we provide you the information. You don't like the way we sort it your own way. But that's the idea of it. If we want to help you manage that process, and then you can graph the total score and see how it's going down over time. Because if you don't intend on fixing this, you actually don't want to know in what ways you're not compliant. You only want to know if you plan on fixing it, because otherwise it looks like, when lawsuits come and there becomes disclosure and things like that, you want to show that it's going down, not that it's going up or staying flat. You want to show that you're doing your job. But the good thing is now you can, how many people think they have managers that like graphs? Yeah, so we could do a graph that lets them show how you're actually getting your job done. Which I think that's a good thing, right? You can eliminate rules. Yeah, that sometimes that's the right answer. But you can also do it by actually fixing the problems. I mean, I know that's a radical idea, but you could actually fix the problems. But so anyway, a little more on the best practice analysis. They're triggered by discovery updates, and we don't evaluate them daily, weekly, quarterly, or annually. We evaluate them when something changes. Gosh, isn't that interesting? In other words, you know almost right away that something has changed, and then you know that you either got better or you got worse when that happened, right? You can discover more or less anything you want. Writing a discovery agent basically means whatever domain you want to discover. For example, maybe PAM rules, maybe proxys, maybe login, SE login defs, whatever. You write a script that spits that, transforms that into JSON, which is not rocket science. And then you teach us where it is, and we run it for you. And we keep it up to date in the database. Not hard. Then if you want to write rules based on that, you can. Or if you just want to have it in the database so you can query it, there you go. It's there. And as I said, there are alerts and various kinds of reports available. And here's some of the stuff we want to do in the future, because once I get into the demo, I get carried away. So I want to tell you this because I don't want to forget this. We want to coordinate with security vendor updates. So for example, when Red Hat comes out with a new patch, we want to then ding the security scores of all the machines that have that vulnerability and not unpatched vulnerability. And of course, because of the way discovery works, once you apply the patch, then that score would go back up because that's integrated into the process as well. We know what packages you have on the machines. We just don't currently update the security score based on that. We ought to. So we want to do interesting things with checksums. We currently collect the checksums on everything that's network facing. Of course, then going to your vendors and getting whitelists and bringing them in, that's a good thing. Blacklists for some things, that's a good thing. And one of the other things we can do, because we have it all in one place, we can do what I call minority reports, which is to say, did you know you have 99 copies of this library that are the same and one that's different? Oh, maybe that's not a good thing, right? Or maybe it is a good thing. Maybe it's the only one that's not hacked. But it's something worth looking into in any case. And we want to integrate with SIMs, and we'd like to add some role-based access controls on some of the queries so that you can do this more in an environment where you don't have to be a security person to be allowed to get at this data, so that people can see the data that's appropriate to them according to their role. And the question I want to ask you, and you can think about this, and I want to invite your input, is what else should we be doing, right? Imagine you could know anything you wanted to know about your systems, and then what would you want to know, and what would you do with it? What would you do about it, right? And so that's kind of that's the space we play in here. The question is, what's interesting to you? Because it doesn't matter what I think's interesting. Nobody cares what I think. What matters is what you think. What matters is what you think. So a little about the demo. In this demo, everything is discovered. Nothing at all is configured manually. I don't even tell it where to find the central server. It happens to be on the same machine because that makes the demo easier. But it doesn't have to be. It discovers that as well. We'll show you things that need hardening. Walk you through the process of what this sort order looks like for the triaging of problems. How to do a visualization of an attack surface, because I know all the services you're offering. I know what ports they're on, and it's in a graph database, so it's natural to be able to visualize some of these things. And I'll show you a little demo of what packages and versions are on machines, and it'll include a little Docker discovery. well, I may not be running a Docker instance right now, so if I'm not, it won't discover it because I don't think I set that up this morning. So, but it would if I had it running. So, so the demo now, do this and go over here. Okay, so I have a script, cleverly named script called demo, and it'll wipe out the database. Oh yeah, right, sudo. So it's actually going through here. This thing is back to not working very well. But anyway, it doesn't matter. Up here at the top, it says erase DB, run in the foreground. So we're starting it up. It's going in the foreground. We've now it says in the resetting connection, that means that it's now gotten a connection from one of its agents, right? And now it's starting to do discovery, and it's showing you what rules it's failing here. This particular first discovery is off of etsy auditd.conf, and it's saying that we passed some rules and failed some rules. And the security IDs, it says NIST, those are actually DISA STIG identifiers. And we'll show you something else that goes with that in just a minute. And now we're evaluating some best practice rules on SSHD configuration. And we pass some and we fail some. And this is all happening as the discovery comes in. Actually, I deliberately kind of slowed the discovery coming in so that if you start up a bunch of machines at once, we don't get flooded so much. It spreads it out over a couple minutes. And now we're going on to some things. Where are we here? File and directory attributes, and we're passing some and failing some. And so in this case, by the way, this failure here was on. It says that one of the shadow files was readable by group. Readable by. Anyway, it doesn't like something about that. I don't remember exactly what it is. And going on here, and as it's doing discovery on this set of attributes, that set of attributes, this set of files, and so on, and it continues on through here. Now, and it also says here about some services are now operational. So once it's discovered what services the machine is offering, it's actually going out and monitoring those services as well. It says, well, I see you're running Neo4j. Why don't I just monitor it for you? I see you're running SSHD. Why don't I just monitor it for you? So it's doing this kind of stuff here. It's coming down through here. And the last thing it's come up with here is, now I did a tail on, I think this is, I have to go over here, yeah. So I did this is a tail of syslog. So if you look in there, it's got a URL into the itbestpractices.info project. People in the back can kind of see that, I hope, a little bit. But if you open that up, open link, I'm not sure quite where my browser is. It's in the wrong window. Let's put it over here. No, I don't want you to restore it. So people in the back can kind of see that too. So it tells you that this is a medium severity problem, and you're not supposed to set ICMPv4 redirects by default. And it goes on to explain it in a little more detail and how to check if it's correct. And if you continue on a little farther, it then tells you how to fix it. Because actually checking this value is like, is value equal to 0, right? That's a very simple piece of code. But the explanation for it is a lot harder. It's actually, because if you don't know what these rules mean or what their significance is, you're probably not going to fix them, right? And so the tying of these two together, I think, makes it much, much more useful. And this basically is the fundamental of what the IT Best Practices Project is this kind of information, right? And there's a website for it, and there's a source control under GitHub, and it's an open source project, right? And there are a few rules there that don't come from DISA STIGs that I've written, and actually it doesn't have to be all security rules. There's actually one networking rule too. But this is the idea of what this does. Now let's go on and see what some of the other stuff I thought about doing in the demo here is. Oh yeah, this is cool. So let's make this bigger. Oh yeah, it did make it bigger. Oh no, went on to something else. That's not the right file. What did I do? I think I went to the next file. I'm not sure exactly how I did that. So let's get rid of this program and try again. View, zoom in. Okay, so this, oh, it's on my screen but not on yours. Oh, let's put it on your screen. Okay, so this is a visualization of the attack surface for this machine right now. And I'll see if I can explain this. It would be a lot better if this thing were working. Oh, it's sort of working. No, it's not working again. Oh, no, this is the one that worked better. That's why it's up here. Yeah, okay. So this is the system. This is a representation of the system itself. You see it's in bold red, and it says we have a risk score of 57. The way the risk score is calculated is if you have a low priority violation, it's worth 1 point. Medium priority is worth 2 points. And anybody going to guess what high priority is? 3. So we have a total, and that's why it's red, is because it has, basically illustrates it bolder and bolder up to a certain point, and of course if you don't have any, it would be black and thin, right, rather than bold and red. So now it's decided to stop working again. I needed to replace the batteries before I got here, I guess. But so what we have here is a bunch of different services. Here is a Java program, Dropbox. Now, unfortunately, it's scrolled off the screen here. Let me see if I can scroll this. I'm not sure if I can or not. Yeah, okay. So SSHD is running here as root. Now, this looks like either I had a bug in. Oh, this is an old version of this file. That's the problem. This should be red, and in fact, in the current version of the software it is. I cached this file because it takes a little while to run. So this is SSHD, which is listening on these IP port combinations. This is Dropbox, which is both talking out an outbound connection to Dropbox here and an inbound connection to talk to other people on Dropbox. RPC bind. This is Neo4j, and I was apparently running Vino server at this time as well. Like I said, I'm not sure what happened to the version I had here that was, oh, right. And this is a different kind of visualization, which I can't show you because it's not bold enough. So anyway, the idea is that these are the IP ports that people can get in that you're offering services on. Up here are the IP ports for services we're requesting outside. Thanks. So anyway, this is an idea. Show you an idea what the visualization looks like. Let's go on to something else. Sure, this is a good one. So let's look at all the packages on the machine. And if I can go back over here, get rid of this. Okay. Maybe I should sit down. Apparently, I'm not very good at mousing. There we go. So let's get rid of this. Now, okay. So let's go here. Control-Shift-V. So this is a query on all the packages on all the machines. So that's so what we have here are this machine, System 76, has a package called Ubuntu One Client Data. I mean, this is just some of the examples of things on here. That's all the packages and you see the version numbers out there too. And what kind of these happen to be pip packages. It finds pip packages, RPM packages, deb packages, and so on. Right, all the different kinds of packaging, Node.js packages, and so on. And you can also query for specific packages. Let me go back here and find this again. So let's look at the version of the database I'm using here, right? And now it just came back with one answer. I don't know if people in the back can see that, but it basically says, I'm running version 3.0.4 of Neo4j. So we have this stuff in the database. Whenever it's updated, the database is updated on this kind of stuff and lots of other kinds of things as well. These are just simple examples of the kind of stuff, the kind of things that you can have in the database here. As I said, it includes deb packages, RPM packages, Python pip packages, Ruby gems, PHP packages, and Node.js npm packages. You can do others as well. It's just I know how to do those. And this is, as I said before, an open source project. And let's see what I can have time to do. Maybe one more. Oh yeah, let's do one of these. So let's look at the most critical problems that we have from an overall perspective, and I'll explain this. I talked to you about triaging before. So what we have here at the bottom, this is not the. I guess I should have just gotten fresh batteries, but if you look here, I'm going to have to stand next to it. Sorry. If you look, this is the head at the bottom. So it says here that procsys accounts to 16 points on this machine, and here are the rules by order of how much the individual rule costs you, and then the next area that costs the most is PAM rules, and so on and so on. The idea is if you wanted to know what to attack, you'd want to attack the things where you have the biggest bang for your buck. And that means let's go learn how procsys rules work and how we set them up. So we'll go investigate that, look at the procsys rules, look at these particular rules starting from here, come to understand them, fix them, and then distribute them out. And when you do, you'll get your biggest bang for your buck. Then you can attack the PAM rules and so on down the line. It gives you a way of attacking it to help you know what to do in order to fix all these problems. So this is the basic idea of what we do here. And is this making sense to people? And as I said, we do the rules, we do all these different kind of things. It's really, it's a very broad project, perhaps overly ambitious, could be. Not an unfair comment. Let's see, where's my mouse? Control Shift 5. No, Function Shift 5. F5. Okay. Oh, I'm going the wrong way. Oops. Okay, come on. I don't need that. Now I went too far. So, to summarize what we're talking about here, we know more about your systems than you do. Anybody here think that security is like warfare? Yeah. Sun Tzu says, if you know yourself and you know your enemy, you need not fear the result of 100 battles. We help you know yourself like nobody else. We know more about your systems than you do, your admins do, and anyone knows. We can discover anything you'd like to know. Discovery keeps everything up to date, more or less quasi-real time. Best practice auditing, of course, is this best practice auditing is continuous. It's not quarterly, annually, or whatever. Our scoring system, as I mentioned, helps you figure out how to attack your problems. Discovery includes, it has near zero configuration. This is just a summary of what I think is cool about it. We include Docker containers in our discovery. System monitors servers and services for good measure. So in terms of your sysadmin staff getting value out of it, this helps you give more value to encourage them to be able to use it. And everybody to work from the same playbook of what's on these systems for real. System includes, we have an event API that says it'll let you know when things happen so you can trigger whatever events you want, hook it into your SEM, into custom scripts, whatever. And it scales and unusually well. So this is a little more about this. If you go to a category getting started, it'll show you walk through 4 different places that you can go to find out how to get started with this. And to see some similar demos, there's some demos online as well. These are in the slide deck. And of course, the idea is get assimilated. Try this out. Give it a shot and contribute to it. And of course, resistance is futile. Questions? Yes?
What is the overhead on your agent?
So the question is, what's the overhead on the agent? And the answer is, it is written in C, and its footprint is measured in megabytes, not gigabytes. And being so that depends on how often you want to check these things. It's still measured in a handful of percentages in the worst case. Like 1-2%, something like that. It can be less than that if you want. It's a question of, if it's a problem, make it check less often. Right now we're currently having it check on intervals of seconds, but you can have it check on intervals of minutes. How often do you need to know these things? What's the frequency that matters to you? Then you set it accordingly. Does that make sense? It's not a very good answer, but it's the best I can give you.
Well, it's just that, a lot of places that they have a lot of agents already running on machines.
This is as small and lightweight an agent as you're likely to run across. I perfectly understand that.
Yeah.
Give it a shot and tell me what your feedback is. More questions. Blue in the back. Right. So one of the things if we're running on real or virtual machines but not clouds, we also listen for ARP packets, so we know all the IP addresses and MAC addresses of everything on your subnets. And that goes in the database. That's a query that I didn't have a chance to show you because we don't have enough time. Yes, question over here. 2 questions. There's a Windows port in progress, but I don't know when it's going to get done. So the question is there a Windows client? And the answer is, it was architected to have a Windows implementation from the beginning, and I have somebody working on a piece of it. I don't know how fast it's going to get done. It's open source. Come help me.
And also, how are you not a security risk yourself?
My stuff? Oh, absolutely. So let me make something absolutely clear. What this database, it is the buried treasure map for your environment, right? Totally understand that. But I've been aware of that from the beginning, and that's all you can really do. The point is, if you make valuable information, the problem is it's valuable, right? And you need to protect it. I mean,
Is there anything inherent in how you're doing this? If I get a hold of
all the communication is encrypted with public key encryption. We can talk about that. That's obviously a complicated question, and it's a good one to discuss here. I've been given a lot of thought, and I've done what I think I know to do, and I'm certainly happy to hear more input. Let's go on, though, if that's all right for right now. And I would like to talk about that some more. Yes, you.
How does the actual communication between the clients work? You said it was hand-holding.
So there are heartbeats, UDP heartbeats, and the communication with the central server is also UDP. But the stuff with the central server is authenticated, encrypted, compressed, blah, 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 and with public key encryption.
But more in terms of how do they actually discover each other?
They don't discover each other. They wake up and say, hello, here I am. The central server says, okay, here's your neighbors. Because we need to know about them, so while we're talking to them, we tell them where to splice into the ring. In the back, in the very back, yeah, the guy, yeah, with the hat and the little beard. Sorry, it's like, how am I going to describe it? I didn't hear the question. I heard about common checks.
Does it use raw SCAP content, or did you pull out like a small subset of common checks between the different sticks?
Well, first of all, we have the checks we have, which is not all we want to have. The checks we're currently doing are mostly based off the DISA STIGs. The thing is, it has to be mechanically observable. I mean, I can't observe whether somebody signed a paper log coming into the data center.
All right, one more question.
One more question in the beard there.
You mentioned that the communication with the central server is UDP communication is encrypted. What about the communications between neighboring nodes?
That's just heartbeats. There's no content to it other than I'm alive.
Okay.
And because the key distribution problem with that is just horrific. So we don't do it. It's just we trust at that level. We provide that level of trust for free. And yeah, you could spoof it. The problem with when you screw with a monitoring system, you're likely to get observed. It's not the thing you usually want to screw with if you're an attacker, because if you do it and you don't do it right, you're going to get observed, because it's the point of this system to observe you.
All right. Thank you.
Thanks much for your
coming to
time.
talk. Let's give a big round of applause to Alan. And feel free to stay in here for our next talk, or go check out some of the sponsors out in the chill out room, wander around.